Okay, so we're going to go through a couple of worked examples on transforming these trigonometric functions. So we'll start off with one, and it's already been done just to kind of save a little bit of time with drawing, but we'll walk through all the steps. So we have y equals 3 cotangent of 2x. So first and foremost, we need to look at our equation that is of the form a trig function. We'll write it like this, omega x. Okay, so in this case, our omega is our b, right, as another form, and it's equal to 2. So the normal period of cotangent is just pi. So we take the period and divide it by 2. So that gives us pi over 2. Similarly, we look at our a. In this case, our a is 3, so our amplitude becomes 3. In the tangent one that we did before, we didn't actually we didn't plot any points to show what that would look like, but I'm going to go through and just plot those on the tangent one that we did earlier and right here just to show you what it looks like. It's a little bit less obvious for tangent and cotangent. For secant, cosecant, sine, and all that, it's a lot. It's really obvious what it does, right? I mean, it stretches it, with secant and cosecant because there's this gap between the negative and the positive portion. That gap grows or shrinks based on the amplitude. And for sine and cosine, the height of the waves grow or shrink. It's a little bit less obvious what it does with cotangent and tangent, but we'll go ahead and put those points on there just to illustrate this. Okay, so we know that our period is pi over 2. We know that our amplitude is 3. So we're going to go down here to our special points, which are normally 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now we're going to take those and we're going to divide them by 2, right? Same as we did to the period, which gives us 0, pi over 4, pi over 2, 3 pi over 4, and pi. So those are what we use as our new special points right here. And similarly, they're negative versions here. Okay. So now we just graph it normally, right? The amplitude, it's not negative, so it means it's not flipped. So we know the shape of cotangent. It opens up to the left, positive to the left, and then negative to the right. And so we graph it here in green. So what does the amplitude do for tangent and cotangent? Well, the easiest way to think about it is to think about what it does to where those things would normally be 1, right? When we graphed secant, cosecant, and sine and cosine, we tended to think about where the functions would be 1 or -1 and plot the points, multiplied or divided by whatever the amplitude is. So we're going to do the same thing. So we're going to ask, okay, where is cotangent 1 and where is cotangent -1? So we have the same situation here where we figure out what the cotangent of what theta gives cotangent of 1. It's pi over 4 and 5 pi over 4. -1 is 3 pi over 4 and 7 pi over 4. So we're going to just divide it by 2, same as we did with the period and with these special points. So pi over 8 and 5 pi over 8 are when cotangent of 2 theta would be 1, and 3 pi over 8 and 7 pi over 8 where cotangent of 2 theta would be -1. So we're going to go over here and we're going to plot these, or we're going to put these on our graph, and we'll put the negative versions too. And these are our points. Now we have our special points and then our -1 points because we're going to deal with the amplitude. And so if cotangent at pi over 8 should be 1, it is now 3, right? And similarly at 3 pi over 8, right? Originally 3 pi over 4, now 3 pi over 8, it should be -1, but now it's -3. And we do the same thing for all of these. So that is what the amplitude does to the tangent and cotangent. Again, it doesn't make it look as different as the other functions because these are continuous, and they don't have max and mins quite like cotangent quite like secant and cosecant and all those that have really obvious discontinuities and jumps, or secant or sine and cosine that have really obvious maxes or mins. But we can go up here to the tangent and just finish this off. So we have here, where is tangent theta? Oh, let me make sure we can see it. So we have 3 tangent of 4x. We already graphed what the function looks like. We already found the period, which is normally pi. So I actually realized that we have an error here. Our graph is actually perfectly fine. And in fact, this is a good thing to double check, is make sure that our what we have written down analytically and what we have graphically is the same. So this is an error right here. So remember, the period of tangent and cotangent are different from the period of all the others. It's just pi. So we have our omega equals b equals 4. So this is pi over 4. Now again, it doesn't actually change any of our special points or anything like that. We did all that perfectly correct. We just have to be careful with this period, that we remember that our tangent and cotangent starting period is just. So that means that, let's double check and make sure our graph looks good. And yeah, we have negative pi over 8 to pi over 8, which is a distance of pi over 4, and it repeats. Similar, pi over 8 to 3 pi over 8, which is a distance of pi over 4, and it repeats. So we're in good shape there. So our graph is perfectly fine. We just, I just made this error right here. Period is not 2 pi, it's just pi. So graphically we're good, but we got to make sure analytically that we're on the right track as well. Okay. So we'll go ahead and draw these extra points to really show what the amplitude looks like with tangent. So tangent is normally 1 at pi over 4 and 5 pi over 4. So we're going to divide that by 4, and we get pi over 16 and 5 pi over 16. Tangent is normally negative 1 at 3 pi over 4, 7 pi over 4. So that becomes 3 pi over 16 and 7 pi over 16. So we'll go ahead and make these new points on our graph. And we can, normally it would be 1 and negative 1 of those points, right? But now it is 3, negative 3. And that is what it looks like. All right, we'll do another quick example with cosecant. So here is cosecant of x minus 1. So this one I haven't done yet because I want to show what happened, what this negative 1 does out front, or excuse me, that's outside of the argument. So the period is 2 pi, but in this case we have nothing multiplying or dividing in the argument, so the period stays 2 pi. The amplitude is 2 because our a here is 2, so absolute value of a is 2. So I went ahead and marked 2, 1, negative 1, negative 2, and 3, and we're going to see why in a second. So let's go down here to our special points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those don't change, right? Because we haven't done anything to the period. And so now we can go ahead and put our asymptotes. So where do our asymptotes normally occur? So cosecant of x is equal to 1 over sine of x. So wherever sine is 0, those are our asymptotes. So let's go ahead and put our asymptotes here, and sine of 0 pi, and a 2 pi, negative pi, and negative 2 pi. Okay. All right, I'm going to grab these points down here and just go ahead and move them a little bit so they're out of the way. Perfect. Let's go ahead and bring our asymptotes back. All right, so now we can ask, okay, so at pi over 2, cosecant should be 1, but we've multiplied it by 2, so it should be 2, but now we have to be careful because we've now subtracted 1. So it actually sits right here. Okay, how about at 3 pi over 2? So normally it should be negative 1, but then we multiply it by 2, but we subtract 1, so it actually looks like this. Similarly, we can go down here and we'll find the same situation. It's -3 down here, and up here it is just 1. So this is what ends up happening to our cosecant function, is we multiplied everything by 2, so it should normally be 2 and -2, but then we had to subtract 1, so that becomes 1 and -3. Make it a little nicer here. There you go. So these are just a couple of examples. Again, I want to stress that we need to be careful with the period of tangent and cotangent. They're not 2 pi, they're actually just pi. So that was a mistake on my part that is interesting, because when we graph it, you know, we do the graphing correctly and the graph shows, but we just have to be careful when we write the period here and here. Now, of course, you should be able to recognize, right? You should, you know, double check and make sure that what your graph and what you have written are the same, and that'll help you catch those kinds of errors. Okay, so I hope this helps, and if there are any more questions, please let me know.